To integrate 1 over x, we just need to look up 1 over x in our table of derivatives, and you can see that natural log of x, if I differentiate it, will give me 1 over x. So there's f of x and there's f dash of x. The problem is, to go the other way, 1 over x is defined, here's our graph of 1 over x, for positive and negative values of x, whereas natural log of x is only defined for positive values of x. So if I integrate 1 over x, and I said it was natural log of x plus c, we'd have a problem, because it's only defined for positive values. And we've obviously got a gradient function for these negative values down here. So it actually turns out that the way to do it is to have the absolute value of x. So if I took the absolute value of the x coordinate of this here, I would actually end up getting of the natural log of the x coordinate of the natural log function, we will end up getting another graph, and it will look something like that. On the other side, that is the gradient function for this curve down here. Okay, so the same logic applies. 3 times 1 over x is basically what I've got here. So I've got, ends up being 3 times natural log of absolute value of x. Okay. The other point that you can make here is, if we have a table, and you'll see this in your table, that if you've got natural log of f of x, I told you that would differentiate to natural. Would it go to f of x, f dash of x over f of x? That's so that's integrating. Okay. So sorry. That's differentiating. So going from natural log of f of x will go to f dash of x over f of x if I differentiated. So to go the other way, to integrate, so this is to give us the actual function, we want to have natural log of what's in there. However, if I differentiated this, I'd have a 3 in the front, so I better divide by 3. Okay, just to clarify that, it's always natural log of the function that's on the bottom, but then you need to rethink how would I reverse it. Okay, and how you reverse it is you're going to have to divide by that 3 here. Okay, this is the last one. They're deliberately just trying to add some extra complication to this. If I divided this x by this x, I'd get a 1, and then I'm left with 2 over x. That's just actually rewriting it as another fraction. So 1 integrates to x, and 2 over x integrates to 2 natural log of x. That's terrible handwriting. Natural log of x plus c. Okay, so that's where we get to. So every time you've got a function on the bottom that's just x, you're going to go to natural log of x. If you've got a function that's almost just x, like 3x minus 7, you're going to differentiate that and just divide by what that is.